All right, let's go ahead and get started with another one. So today we're talking about function operations. Functions, things like f of x or g of x or y equals, basically anything that maps one input to one output. We're going to talk about what can I do with these guys. We're going to add them, subtract them, multiply them, divide them, and then later on we're going to do compositions of functions. But first off, just a simple example. Let's say f of x is a function representing, for example, the speed of the airplane you're traveling in. Say it's 415 miles per hour, and we haven't labeled that, but let's just say that's true. And g of x is the speed of the wind, 30 miles an hour. So f of x represents the speed of your airplane, g of x represents the speed of your wind. When I add them together, just as you might expect, I can simply take f of x and add it to g of x. So the speed, let's say the wind is blowing behind the plane, accelerating the plane, I can just add them up. So the total speed combined is 415x plus 30x, so 445x. This just demonstrates the kind of basic rules that we can go by here. It's pretty obvious. F plus g of x just equals f of x plus g of x. F minus g of x equals f of x minus g of x. F times g of x is f of x times g of x. And f over g of x is equal to f of x over g of x. And the only one that you really have to be careful with for this one is g of x here when you divide. Make sure not to divide by 0. All right, so you're going to have to limit your domain when we're doing that. Okay, so let's go ahead and try a few more practice problems. So for the next couple of problems, let's let f of x equals 2x squared plus x minus 3, g of x equals x minus 1. Let's perform the function operation, then find the domain. And the domain, again, is our set of all input values. Remember, the range is output. Domain is input. That is, what can x be? Is there any value of x that will not work? So, for example, two key things that cause x something not to work for x is some value of x that causes me to divide by 0, or something that causes me to get, for example, a negative inside a square root or a fourth root or something like that. So we'll practice finding the domain as well. So first off, let's take f of plus g of x. F plus g of x. So that's just going to be f of x plus g of x. And we'll just substitute in. That's going to be 2x squared plus x minus 3 plus x minus 1. That's f of x plus g of x. And then since it's plus, we just combine like terms. We get 2x squared, 1x and 1x, so that's 2x, negative 3 minus 1 minus 4. All right, so we look at this. This is our f plus g of x function. Let's find our domain. All right, the domain, is there any value of x that's not going to work for this? I could plug in like positive numbers, like 1 gets me an output, 5, 10, 30, 0 also works. If I plug in 0 here, I get negative 4 as my output. Negative numbers also work. In fact, any polynomial here is just going to be just fine. I'm not going to divide by 0. I don't have any negative square roots, anything like that. So my domain is just going to be all real numbers. All real numbers. Or you could just put the little r guy. Okay, let's try another one. Number 3. Let's do f times g of x, which I can just write as f of x times g of x. F of x times g of x. So that's going to give us 2x squared plus x minus 3 times x minus 1. And we're going to multiply that out. I'll go ahead and draw a little box. So we'll do 3 and 2 here, so 2x squared plus x minus 3, x minus 1. So 2x cubed minus 2x squared plus x squared minus x minus 3x, and negative times a negative positive 3. And we can combine our like terms. We're going to get 2x cubed, negative 2 and positive 1 makes a minus x squared. Negative x minus 3x makes a negative 4x plus 3. I should box these. Okay, so we get that, and our domain. Again, positive numbers work, fractions, decimals, negatives, zeros, things like pi, everything works. There's nothing that's going to cause me to do division by 0 or have a negative inside a square roots argument. Our domain is going to be all real numbers. Okay, let's try one more here. Division, so we'll call this one number 4. Let's do f over g of x. So that's going to give us f of x in numerator, so 2x squared, was that plus x minus 3, all over x minus 1. Okay, we learned that we can simplify this. I can't just cross off these x's, but if I could factor this guy, maybe it'll simplify with this x minus 1. So let's try and factor this. Let me go ahead and do that up here. So I'm going to do this by grouping method. So a times c is -6. Our b is 1. So I'm going to find two numbers that multiply by -6, add up to 1. So let's try 3 and -2. That multiplies and that adds. Okay, since a is not 1, we're going to rewrite it. So 2x squared, I'm going to use these two middle numbers here. So 2x squared, my pen just fell down, plus 3x minus 2x and minus 3. Okay, we do that. There we go, focus. Split it. Let's take the GCF over here. That's going to be x, 2x plus 3. Copy that guy over, 2x plus 3. And therefore I fill this in, that needs to be a -1. So our factors are going to be x minus 1 times 2x plus 3 all over x minus 1. Okay, great. So now I can see that I have an equivalent form of 1 here, so I can cross that out, and we just get 2x plus 3. All right. As for the domain, we just need to think, all right, every x is okay here. Every x is okay except I could divide by 0. The number 1 would cause me to divide by 0, so our domain is all reals, all real numbers, except x equals 1. Okay, that will cause me to divide by 0, so it is not in my domain.